Hello everyone. So today we're just going to briefly go over a couple different functions and in particular what the dimension means when you're looking at functions documentation. And so this is also going to show you how to sum across rows or take the maximum across rows or the minimum across rows, etc. So first things first is let's go ahead and create a matrix. So I'm just going to call this 1, 5, 13. And then for our second row, we might do 2, 4, 6, right? And so I've now defined my A, good to go. So I know that if I take the sum of A, my result is the sum of each column as a row vector. And so this is something maybe that you want to do, I don't know. But what if we want to take the sum of each row? So I want to add 1, 5, and 13, and 2, 4, and 6. Well, the way that we do that with sum is we do A, comma, 2, right? And so now we get our result. And this is, in fact, what we should get. So this 2 is indicating the dimension that we want to sum along, essentially. So for most of what you'll be doing throughout the semester, you'll either be summing along each column, which means you can do either A just by itself, or you can do A comma 1, and that's the exact same thing, right? So the 1 is implied if you don't put anything there. And then so you know that it goes with columns. We know that for MATLAB indexing counts 1, 2, 3, 4, 5, 6, right? So that also counts down each column. So we know we work down columns first. That's the easiest way to remember this. Now, sum works a little differently than some of the other functions that we use. So if I go to the documentation and I click on sum, you can see that we were using sum in this way, where we have A, which is our matrix, and then our dimension. And so this dimension is either down the columns, which is 1, or across the rows, which is 2. And so we define the dimension as 2. Now, if we look at mean and the documentation for, not mean, max. So sum and mean, the way to remember this is sum and mean both are sort of like algebraic functions, right? You can find the sum by adding everything up. You can find the mean by adding everything up and dividing by the number of things you have. The max, you're never adding anything. And so same for max, same for min. And both max and min work in this way, where you have this these empty brackets before your dimension. So I can explain why, but I won't, as to why we need the empty brackets, because we never use this in our class, and so we never use this form. We always are using this form, or just this form. So if I want to say the max of A, we know that this is going to work down each column, and sure enough, it does. Now, if I want to take the max of A and our across each row, this will not work. This gives us something weird, right? It gives us 2. It replaces the 2 here, and then it gives us everything else. And so the reason for that is because it's taking the max at each individual point between 2 matrices, and you don't need to worry about it. The proper way to use max to get the max of rows is to do empty brackets, comma, 2, and there you go. Now, one final thing, and I'm just going to type A here so that we have it on the screen. There is another way to do this, although I don't recommend it. If you want, you can take the max of A transpose, and that will give you a row vector of the max of each row. Now, you have to remember that it's a row vector, so more commonly, if you wanted to get it in the exact same format as this up here, right? If you wanted the exact same format as this output, what you would have to do is you'd actually have to take the transpose of that. And so if we take that, then we get this is exactly the same as this, right? So just a little quick demo of how those functions are the same and different, and hope you guys have enjoyed it. Let me stop recording. Have a good one.